Alright, welcome back. So besides the table scanning operation, some other operation may also need to implement it with some concrete, the physical operation, with some concrete algorithms. In this video, we will show you with some examples for the one-pass algorithm. There are the selection as well as the projection. I hope you still remember the selection as well as the projection. Selection is denoted by the sigma R. It's the selection on the relation R based on some conditions, of course. The target is to select some rows or some instant tuples which can match the condition from the relation R. As to the projection, actually it is to project some attributes or some columns from this relation R. We have a very large table and we have to project some columns instead, which will be based on the projection pi R. So both of these operations can be done with one-pass algorithm. And here we use the algorithm, both of them can be implemented with a tuple at a time algorithms. In other words, we can read a block at a time and use one memory buffer and to produce the output. And we can read all the data we have and into the memory, and then we can generate the output with the memory, based on the memory. So, then the time cost for these kinds of operations actually really depends on the memory size as well as the table R. If this R is clustered as we mentioned before, so in other words, for each block it will store all the records from this table. If so, then we just need to locate the blocks for accessing the records. And the time cost will be about BR, the number of blocks for storing R in the memory. If so, then for both selection and project, the time cost will be BR. However, if this relation R is unclustered, in other words, for the records and they can be placed in the blocks with many other tables, it is unclustered. If we plan to find the tuples matching our requirements for the condition as well as accessing all the tuples, if so, the time cost will be about TR, the number of tuples in R. The main reason is because for both of these two operators, they may have to access all the tuples. For this one, we have to match all the tuples with a condition, which is not shown here for the selection. To access all the tuples, we have to access them. If R is clustered, then we just need to access all the blocks. If this R is unclustered, we have to go over all the tuples. It will be similar for projection. We have to project the corresponding attribute for all the tuples. In other words, we also have to access all the tuples. It also depends on the R, and the time cost will be BR and TR depending on the conditions. And here we also have some assumption, because we mentioned here in the beginning, we assume this memory size is not enough. Here we have an assumption that this M is actually larger or equal to 1 for the input buffer. This M, if you still remember, it denotes the number of blocks in the memory. It will be regardless of the B, this number of blocks. In other words, given the input buffer, it is in the memory, then we can use these unary operators, is the selection or projection, to generate the output to the output buffer. So this is for the one-pass algorithm on the selection as well as projection.